Hello Internet! In this video we are going to be working on a world height shader. I know that sounds simple, but if you've ever seen like those submarine underground pictures where they have like the layered heights, so it's like a layer, or the cartographic maps, GIS maps where they have the heights measured. I don't know exactly what they're called. I figured we could make one of those. I don't actually know how that's going to work. But what I'm thinking is we're going to do a bunch of layered planes that are going to use the same material. And then we're going to use the world height of those planes to actually determine what to draw. So we're going to kind of project a 2D grayscale map, one of these guys, off into our 3D space. So this is going to be our height map, and then we have the X and Y here. So that's going to project this up, sort of like the terrain height map. But we're going to try to represent it using lines, which means we're going to write a shader. So I haven't really thought this out. I just was like, this will be cool, so we're going to do it. And I'm running late on this video anyway, so I didn't want to get into something that was too crazy, though I don't know how well this is going to go. So we're going to do like a height shader. And so we can really use the normal height shader, or the normal surface shader we get. We're just going to need a world position, and we're going to use just the y coordinate of that. So we're going to have a plane on the xz axis, so flat across this plane here, and then we're going to project up from 0, and then we just need to have a range. So we're going to use the range to define that ring, and theoretically that does what we want it to. Or not. I'm not entirely sure what it's going to result in, but I'm sure it'll be interesting. So yeah, we're gonna see where it goes. So I have standard surface shader. We've done this a lot by this point. So we are going to want, we've got sort of our main texture here, glossiness, metallic. I'm gonna actually drop these, and I'm gonna. It might make sense to do like an alpha here, but for now, I'm going to actually just use a clip. So we're actually just not going to draw things that are outside. So I need a projection height, which is going to, so we're effectively projecting that up. So we have, I go back here, we have a grayscale map. Now this is a different image, but you get the idea. This is going to be a grayscale map that's going to be from 0 to 1 in our shader. We need to project that a certain height up, and we're going to use that in our calculation. So it's effectively just a multiplication, but we need to know what that is, and that's what this is going to store. So we've got our projection height. That can just be a float, and we'll initialize it to 1 initially, which is just an easy starting point. And then we're going to have a projection range. So you're going to have a bunch of planes here, and so we don't want to just do at that specific point, because that's going to never happen. We want to give it some sort of padding on either side. So we're going to do projection padding. We'll make that a float, and we'll make it 0.025. Is that what I want? Nah, it's probably not what I want, but we're going to try it anyway. These can all be changed. They're all just settings, so you can do whatever you want with them. We're going to pass both of these in. Do one of them has halves? So there's halves, and then there's floats, and there's something else that I'm totally blanking on. Half is going to be small. It's sort of like a short, if I'm remembering them correctly. Then you have floats, which are 32 bits, and something in between that I don't remember. Fixed. There's a fixed somewhere in there, and I don't know if that goes, if that's bigger than a float or in between, but it's there somewhere. Doesn't particularly matter for this, and I don't think it actually matters for most things. Depending on your shader model, I think they all get cast to the same thing. But on older versions, I think it mattered more. That's a ramble that I probably shouldn't have gone on, because I don't really understand it. I'm going to pull out the metallic and gloss because we got rid of that, which means those are also going away. We're also going to add an emission here equal to our color. So we're going to emit whatever color it is. We don't need an albedo. So this can actually just be a float 3 of 0, 0, 0. So this is a black with some sort of emission. So it's going to emit this color. It's going to glow whatever color we set it to. But everything else is going to be ignored. Then we need to solve for the height. So we're just looking up the height in our height map and multiplying that by the projection height. And so we're doing this. Then I think we can just do this with subtraction. So we can actually just have a clip of our height minus our world pose. How does this work? No, if we do the height, will that work? So we need to figure out if it's within some sort of range. And I'm not sure the best way to do that. I don't know. We'll get to that. So I need the world position, which we just pass in like this, which means this input value now includes the world position. So we can actually solve for the difference here. All right, I know how we're going to do this now. So we're going to have a fixed, let's do a float of our height distance. And so we have the height distance here, which is going to be a, I don't think this matters, but we want the height minus the world pose dot y, which means this needs to be coming from that input value. So this is going to be the difference between the current height of that pixel or that fragment and then the current height of that world position at that fragment. So we're looking at both the height map and we're looking at the actual world position in world space. So now that we have that, we can take, what do we want? We want to clip by our projection range minus the absolute value of that height distance. I was kind of thinking about this as I was going, but what I'm thinking this is going to do, this could be totally wrong, I am not entirely sure. I think this projection range is going to say it's 0.5 or 0.05. If it's 0.05, then we're going to subtract off the difference in height. So if that difference in height is greater than the projection range, it makes it less than 0 and gets clipped. But if it's less than that, if it's within that range, then it doesn't get clipped and it gets drawn. So theoretically, if assuming my logic is correct, this works. We need to take the R component from this just because it's a color coming from a texture. And so we have to multiply that, keep ourselves in floats. There we go. So now we're not pulling out the color from here anymore. We're just pulling out a single height value. And that's why we can multiply by this projection height. And then we plug that in, clip it, and we draw. And so theoretically, this will be everything we need. It's probably not everything we need, but height material. I spelled that wrong. All right, let's see. Do we have a custom? Undefined variable C. Alpha 1. Sure, done. That was easy. Right, we'll plug in our height shader. We get nothing. Stick in a Perlin shader. So we get something, which is a start. I don't know if that's correct or not. So what I'm going to do is drop down this plane here. We're going to do 0, 0, 0. Probably could have made this smaller, but we're going to do 8 high. So I'm actually going to have to tweak this material a bit. Projection height 8. Okay. Oh, because of the black. I see. Well, that's kind of annoying. So when it's fully black, we're drawing the entire ground, which is less cool. How can we fix that? I'm not entirely sure. We can do it this way. I can just lift it up a bit, and that sort of fixes it, but it's not perfect. Yeah. So I think we can use this. What I'm going to do, instead of making each of these manually, I'm going to create a quick script. That's going to just build height map. And so this is just going to layer a ton of planes with that material on it to whatever height we want it to be. So we're going to give it a float. Public float height. Public material. And that should be everything that we need. I'm going to also plug in float. Just a quick offset. I'll set that to like 0.05 initially. Because we just want to be off. Well, it's gonna need to be a little bit bigger than that. I don't want that bottom tier to show up, which we could change our shader to prevent that, but I don't really want to. For now, I just kind of want to manipulate the actual graphic, which may not be the best solution, but we're gonna do it anyway. So there's a game object dot create primitive. So this creates a primitive type, so we can just create a bunch of planes. Do I want to do planes or do I want to do quads? That's a good question. We're going to do planes. So we're going to create a plane for I equal, well, let's do a float. Float y equals our offset, while y is less than our height. Increment y by our step. Ooh, that was interesting. Let's give ourselves a step value, and this way we can actually control how fast we grow this this effect. So the shorter our step size, the more planes we're going to have. So this is going to create a game object. Ooh, what the heck? Object. Cool. And then I just want to grab the render off there. So render, we want to get the component of our, I forget what this is called. That's important to remember. There's an easy way to figure it out though. Just throw something into your scene. Mesh render. I should have known that. Mesh render. There we go. So we're going to grab a mesh render off of this and assign the material equal to our own material. And that way they'll all just match. So now we should be able to throw in a ton of planes. Assuming I did this correctly. We didn't quite get there, actually, now that I'm thinking about that, because we did not update our position. How can we do this? This will work. Transform position equal to vector3.up times our y vector. So the z and x axis, those can be 0, and then we just go up by the y. And that should solve that. Should be super quick. Let's see here. Plug our material in. That's still spelled wrong and it still bugs me, but we're gonna keep it for now. So this should get us like 32 high or 32 planes, each with a step. That is very hard to see. But there you go. So it gets harder to see because we actually clip the other side. But from the top, this actually looks super cool because you can actually like sort of see the height. And since this material is entirely dynamic, we can actually go through here and change the height of this. So I can actually reduce the height of this terrain. You can actually see it a little bit better. So that's sort of what I was going for. I brought over a few other. I'm just using a bunch of Perlin noises for this. Now that I found online that people had already generated, we should write a Perlin noise generator or just a noise generator. So this is, yeah, you get these really cool like height things, and I don't know, that's pretty cool, especially since it's taken us like 15 minutes to write this thing. This one is probably my favorite actually. Just because it's not, the other ones are a little bit hard to tell what's going on. This one looks a little bit more realistic, just because of the way it is. But we can kick this back up so we get a little bit steeper inclines. Or we could reduce the height, say make it 4, and then drop our offset to be like 1.25. So we'll still have 32 planes, but they'll be a lot closer together. So if I drop this back down to within our range, it looks closer. So we get more and more effectively. I don't know. I think it's cool. I think actually we can color it too, because I plug that in, so we can actually do all sorts of cool stuff. So this effect, over the weekend I created a Unity visualization. I think that's what it's called. GitHub repo. So a lot of these effects that I do, I didn't really have a place to put them, so I was doing like gists on GitHub and things like that, and that wasn't really working, just because there's no good way to maintain those because they're just a single file. So I threw together a repository that kind of, all of these like single effects that I put together, they go there. So this is going to end up out there shortly, hopefully before the video goes out, because that just makes the most sense. But yeah, so I don't know, 15 minutes and we got this, which is super cool. Granted, this effect we could probably actually make a little bit better, but yeah, I don't know. For 15 minutes, that looks pretty sweet. So yeah, that's it for this video. I kind of ran out of time. I had a few things that took way more time than I was expecting today. But we're going to hopefully, now that it's May, I'm hoping to get a video every weekday. I kind of said that's what I was going to do from the start, but just because of work and all that other stuff, that hasn't really happened. So I'm hoping to get closer to that schedule, and I'm also hoping we can do a few more live streams. People are asking for that. So yeah, we'll see if I can make that happen. I'm hoping at least once a month, hopefully more than that. Because it's a lot of fun to kind of hang out with you guys and kind of figure out what you're looking into and kind of learn that way. So yeah, we'll see. I am rambling, so I will bring this to an end. But yeah, if you guys want this, the code is going to be in the description. I'm going to try to be better at that because a lot of you just come here for the code, and that's perfectly cool with me. So yeah, if there's anything you guys can think of for using this or other ideas you have, let me know in the comments because I'm always looking for things. So until next time, well, until tomorrow, hopefully. See you, Internet.